Welcome advanced topic students to section 1.6, set operations and compound inequalities. We have some new terminology that we need to go over, and that is intersection and union. So we have two different symbols. Okay, and I guess I'll use this kind of cool green color. Intersection, the symbol for intersection kind of looks like an upside down U shape. And what does that mean? Intersection is when we have two different sets. So for example, this circle is pretty well represented, or a good representation of what we're trying to accomplish. So if we have set A, and A is this blue. So blue, everything that belongs to A, I mean it could be anything. It could be, sorry that bothers me a little bit. I need to make it perfect. It could be anything. It could be any sort of number group or anything like that. We'll say that's the blue group. And then let's say we have, I don't know, let's make it like orange or red. Let's make it this dark red color. And this is set B. And B is anywhere there's red. So that is our group B, okay? Now, intersection, what does that mean? Intersection is where the values belong to both sets. So both sets are, it belongs to both sets. So the intersection where it belongs to both A and it belongs to B. So this would be our intersection right here. So that is our intersection. That little upside down, but it's got a kind of a flat top to it. Okay, this isn't perfect. It really should look something like that. Okay, that's a little bit better. Now union. Union is a little bit different. Union looks like this. Okay, so if you think of the Miami U, and for all those that pay attention to colleges or universities, college football, whatever, the Miami U is union. And what is this? This is values that belong to either set. I capitalized both, so I should probably capitalize either. What is the distinction? What's the difference between both and either? Well, the difference is with the word intersection, we're using the word and. So you need to think the word and. With intersection, we need to think the word or. It can belong to one or the other. With intersection, it has to be both. Only where there's overlap. So when we're talking about intersection, we're talking about where there is overlap. Union, we're talking about everything that belongs to either set. Okay, so overlap versus everything. So if we're talking about the union here, union is going to be everything that's in either A or B. So our union would be everything that's in that, well, it's not that guy. He left the correct designation, but that would be our union, okay? Now, let's put this into example. So we see a Venn diagram here. Let's see an example with actual sets. So we have A is a set of the numbers 1, 2, and 3. B is a set of 2, 3, and 4. First thing we want to find is A, and this is intersection B. So what belongs to both? Which is both in A and in B? Where is their overlap? Oh, sorry. You know what? We'll keep rolling. Sometimes you sneeze. So we look here, we see that we have one in A, one is not in B. So that is not in both. We're only looking for where there is numbers in both. Where are there numbers in both? So 1 is off the list because it is not in both. What about 2? 2 is in both. So 2 is 1. So we're going to create a new little set thing. So 2 is in both. What about 3? We're in luck. 3 is in both. So we have 3 here. And 4, what about 4? Nope, 4 is in B, but not in A. It needs to be in both. So this is A intersection B, just 2 and 3. Okay? So that is how we handle that intersection problem. Now, we're talking about union. Union, we're talking about or. It has to be in one or the other. We're talking about the set of everything, okay? The union. Union, we're thinking about uniting, everything joined together, okay? So let's get our set ready. Here we're talking about 1. 1 is in one of them. It doesn't matter if it's in both. It just has to be in one of them. 2 is in one of them, but we only list it one time. 3 is in both of them, but we only need to list it one time, even though it's in both. And then 4 is in only B, but it doesn't matter. We list 1, 2, 3, 4. That is a set of all numbers. It's a set of everything between A and B. It's the union of both A and B. Those numbers, 1, 2, 3, 4, are either in A or they are in B. Okay, so again, we're thinking or we're thinking both. Okay, here's another problem. 1, 2, 3, 4 is the set of A. 2, 4, 6 is the set of B. We want to find A. What's the symbol? Upside down, intersection. Okay, so intersection of A and B. Now, let's go ahead and break this down. So if we're looking for the intersection, we're looking for something they have in common. It looks like 2 is in both. It looks like 4 is in both. 3, 1, and 6 are all off the table because they're not in both. So our intersection is going to be 2, 4, and that is it. Now, how do you know? Like, let's say it doesn't say the words intersect. How would you know? Well, you need to memorize that this symbol means intersection, and maybe you can say like it intersects the ground or something. And then union, it's like a U. So union, that's a good way to think of union. It's just a U, and then intersection, intersection, I guess. It has an N. I don't know. That's just something off the cuff here. Hope that helps. All right, compound inequality. This relates to compound inequality because we're talking about and or in inequalities. Now, how do we do that? It's a 3-step process. So let's say we have inequalities like this, and then we have inequalities like this, or, okay, what's the first step? Regardless of what type it is, you're going to be doing the same process, which is first solve the inequality. Okay, you need to get x, or the variable, by itself on one side of the inequality sign. Step 2, once you're done with that, so what that means, let me just draw another graphic. So you're going to get x is less than or equal to some number or whatever the case may be. You may have 2 of them, like you have x is less than, and you have x is greater than another number, okay? So you're going to solve for the inequality. Number 2, if it is and, you are going to find the overlap. Just like we found the overlap here, you're going to find the overlap with anytime it says the word and in a compound inequality. What about for the word or? For or, if or, graph both inequalities and then interpret. Now, I want to clarify something real quick. I just thought of this. If we're talking about the overlap, sometimes you need to graph both and then you can see where the overlap is. Okay, so kind of you need to graph both for both of these. But for number 3, most of the time you're going to be graphing both of them and leaving them, but you may need to interpret. Okay, we'll get into that in just a second. So solve the compound inequality and graph the solution set. So the first step is we need to solve the compound inequality. Well, we have 2 different ones here. Let's go ahead and solve the one on the left. We're going to subtract 1 from both sides. Oh, don't forget, this is a great reminder. If you divide or multiply both sides by negative, you're going to flip the sign. Okay, that's something to always keep in mind. Flip inequality. Okay, that's our little reminder. Okay, and I don't know if we're going to run into it, but just in case. X is less than or equal to 8. So we're done with 1, but we have the word and here. So when you do the second one, so we're going to add 2, x is greater than or equal to 5. Okay, so we have these 2 conditions. X is less than 8 and x is greater than or equal to 5. One of the ways I want to break this down, you don't have to do this every time, but this is a good way to think of it. Think of the numbers that satisfy these conditions. Less than 8 or equal to 8, but bigger than 5 or equal to 5. So what numbers come to mind? Well, we could have the number 5. 5 is less than 8. These are possible numbers. Possible numbers. So 5 is less than 8, and it's also bigger than 5. It satisfies both conditions. What about 6? 6 is bigger than 5, and it's less than 8. Good. What about 7? 7 is bigger than 5, and it's less than 8, so we're good with 7. What about 8? 8 is bigger than 5, and it's equal to 8, and we're good there because this is less than or equal to. What about 9? 9 is not is excluded, Okay, it can't be 9 because it is bigger than 8. And it has to be equal to or less than 8. 8.5 is excluded. 4.5 is less than 5. Can't be that because even though it's less than 8, it's smaller than 5. And then we have obviously negative numbers, 0, and so on. Okay, so we know we have a possible range of numbers right there. Now, instead of writing out all the possible values, what's a better practice is to create a graph that visually demonstrates it very quickly. Okay, so what we're going to do here is we're going to put our important numbers here. 5 and 8 are important numbers as indicated in the problem. So obviously 5 and 8 are important. We need to make sure we use the right brackets or parentheses. Remember, we're not using closed dots and open dots anymore. We're using brackets and we're using parentheses, okay? So if we're talking about bigger than 5, we need to have a bracket facing, let me use a different color. We need to have a bracket facing this way, okay? And we're talking about the numbers that are bigger than 5, but we also need to put a bracket less than 8. So it needs to be pointing less than 8, pointing this direction, because it needs to be smaller than 8. It can't be any more than 8. And we're going this direction. We're going in this direction. Now, I wouldn't put arrows on them just yet because you're going to get something that looks like that. So what you do is you just kind of see the direction it's going in, and then you see that the overlap is here. If you were to keep graphing this, you'd keep graphing the first one, the 5 one, it'd go this way, it'd go this way, but you're not going to include those because it's not where both of them overlap. This 5 one does not go this way over here. It can't be less than 5. And this 8 one doesn't go this way because it has to be less than 8. So that's why you don't include those 2 arrows, and it only is the values in between here. Another way to think of this is the interval notation. If we were to do this in interval notation first, which is a good idea actually, you'd have 5 and 8. This is the lower limit. This is the upper limit. And you see that is covered in our graph right here. It's represented there. So that's how we demonstrate in graph and is with that overlap. Okay. Now, anytime it says or, we're thinking, okay, we're talking about one or the other, so we need to graph both of them. Solve the compound inequality and graph the solution. Same process, we're going to solve this first. Let me get my blue out, that's what I used last time. Okay, I have variables on both sides here of this first one. So I'm going to subtract 2x from both sides first. Subtract 2x from both sides, I get 4x. Minus 4 is less than 0. I'm going to add 4 to both sides. 4x is less than 4, divided by 4, I get x is less than 1. Okay, there's my first one. Now I need to do the second one. Obviously here I'm going to divide by negative 3. My alarm's going off because I divided both sides by negative. So I get x. I'm going to flip the sign. I'm going to change the color just so you know I flipped the sign. And I get x is greater than positive 3. Negative divided by negative is a positive, so x is bigger than positive 3, or x is less than 1. Okay? This time we're going to graph both. Okay? We kind of graphed both last time, but we only graphed the overlap. You're going to graph both here, and then you're going to interpret. And the reason why I put interpret is because sometimes you're going to get some weird things. So here we're going to put 1 and 3. These are our important numbers as indicated in the inequality. Important, important. So we're going to graph those numbers for sure. Now we're going to say, okay, we're talking about the values less than 1. Okay, the values less than 1. And it's an open circle. We're not using those anymore. It's not including 1. So the values that make that true are going this way. Okay, it can't be equal to 1, but we can go everything less than 1. Okay, so we're talking the numbers 0, negative 1, 0.5, negative 10, negative a million, okay? All those values are less than 1. We're also talking about the values bigger than 3 or equal to 3. Because it's equal to 3, we need the bracket. So the bracket indicates which way it's pointing. Well, we're talking about the values bigger than 3, so it's pointing to the right. The values bigger than 3, like 4, 5, 6, 7, 100, 20,000, all that. Okay? Now, what do we keep? Well, we keep both of these graphs because we need both. Okay? We need both. We want to include both of them because it says or. We graph everything. So we graph both of these, and that is our solution set. Hope you found this video helpful. I'll see you next time for section 1.7, and thank you for watching.